Following on from the previous video, we were trying to understand why the ratio test works. Why is it that when the limit of this ratio is less than 1, then we can immediately conclude that the original series will converge. So that's what we're trying to understand. Here's a proof. Have a read if you want to. So this is your proof here. So in the previous video, we got to this stage here where I gave you the explanation of a limit, on which you should already know. The definition of limit is that there must exist a capital N where all small n beyond capital N, the original function must lie within some sort of given tolerance. So you should already know this. So that's the true definition of a limit. What it means for a limit of something to exist. It means that for any small n beyond capital N, everything must lie within any given tolerance. Okay, so you should already know this. So we are trying to understand why is it that when the limit of the ratio of the two is less than 1, then we can immediately conclude that the original series will converge. So the strategy that we're going to use to try and understand this is if you look at this, you've got the limit of something. So we need to incorporate the definition of a limit well, we need to somehow incorporate the definition of limits onto this bit here, because it's saying the limit of this thing here. So we need to incorporate the true definition of a limit onto this thing here. So we need to incorporate that. Once we've done that, that will then lead us to something. Well, this something here will then later allow us to say that there must exist a geometric series where the geometric series is always bigger than the original thing. Well, if the geometric series converge, therefore the original thing must also converge. Okay, so we are going to start from here, incorporate the true definition of limits onto this thing here, and then this will then later lead us to something, and then this something here will later allow us to say, oh, there must exist a geometric series that's always above this thing here. Well, if the geometric series is always above that thing and it converges, therefore the original thing must converge. So that's our strategy. Okay, so I will continue in the next video.